Hi, welcome back to Maths Masters. This is the Addition 3 session today. So today we're going to be looking at counting on and the commutative property of addition. Okay, so firstly I want to do a bit of a shout out to Katie. She sent me some excellent work from the Maths session 2, and that was looking at number bonds, and she was finding all different ways and problem solving on there. So well done, Katie, that was great. Okay, keep sending your work to me, email it to me or share it, hashtag mathsmasters or hashtag marvellous mathsmasters. Also, can you subscribe to the channel as well? That'd be fantastic if you could subscribe. I'm not quite sure. There should be some kind of jingle or little snappy slogan that I should be saying there to get you to subscribe. So if anyone could let me know what that is, that would be great and I can use that. Okay, so hopefully you've watched the foundations of counting. That's so important because it explains everything you need for the beginning of counting that we need for addition, subtraction, multiplication and division. So please watch that if you haven't already, and then you'll understand when I'm talking about suppitizing and cardinality of numbers. Okay, so the first thing we're going to look at is counting on. Okay, now this is not counting all, this is counting on. We already know how many are there. We've suppitized or we've used cardinality of numbers, so we've either suppitized where we've recognised how many there are to begin with without having to count them, or we have used cardinality of number and we've counted the set. The last number represents the whole we've got in the set all together. It's the final amount and we know we've got that many. Okay, so we're not counting two separate sets. So, for example, if we have 7 and 2, and these could be 7 anything, 7 and 2, we've got 7 green counters here. And I want to add 2 more on. So I know there's 7 here because I can see that, but you might want to count them. 1, 2, 3, 4, 5, 6, 7. Now you can make a recording of that so that I know I've got 7 to begin with, and I want to add on, count on 2 more. So I'm going to add on 2 more. So I'll do that first. Okay, I know there's 7, so now I'm counting on 2 more. 7, 8, 9. I can touch them to keep me going to the next number. So 7 add 2 is equal to 9. Okay, so what did I start off with to begin with? Well, I started off with 7. What did I add on? I added on 2 more, and altogether the total was 9. So now I have 9 counters altogether. The same can be done with objects, any object. So here I've got 6 apples, and I go to the shop and buy 3 more apples. Okay, so how many have I got all together? So I'm going to count on to find it. I know I've got 6 here, and I'm adding on 3 more. 6, 7, 8, 9. Okay, so can we record that as a number sentence? 6 add 3 more makes 9. Okay, now this is where your number bonds are useful, because numbers like this, if you've practiced and rehearsed your number bonds, you won't need to count on to find numbers like that. You'll instantly know that 6 and 3 goes together to make 9. Okay, one thing to be really careful of, and this is a really common mistake, is when counting on, is that you start what you count on with your last number. So here we've got 7. Sometimes by mistake you might say the 7 there, 7, 8. So what you've got to do is think, okay, there's 7 there and I'm jumping to the next number, so 7, and I'm jumping along 8, 9. Okay, so think about it, you're moving on, it's getting bigger, it's moving to the next number. it's growing. Okay, you've got 7 there. Here we've got 6 apples. We don't want to make the mistake where we say there's 6, 6, 7, 8. Okay, we know there's 6. We go to the next number, which is 7, 8, 9. Okay, and we can record that as a number sentence. Okay, our sheep in the field. We have got 3 sheep in the field. 5 more come along. So that little clouds in a minute. Okay, 5 more come along. How many do we have now? So we can count on. So we started with 3. We've got 3 there. 5, 6, 7, 8, 9. So we can record that as a number sentence. We've got 3, add 1, 2, 3, 4, 5 is equal to 9. Okay, now this is something for parents. We know that sometimes it's easier to count from the bigger number. Children need to see counting from the smaller number to the bigger number at that early stage, because then that will help them to understand the commutative property of addition, where they can be swapped over. Okay, so get children having smaller groups and into bigger groups and vice versa. Okay, so starting with a smaller number and counting on. The next thing we can do is you can work with objects, keep it concrete, you can work with visual, or you can make it abstract. 3 sweets are in a bag. I add 2 more. How many sweets are in the bag now? So this is a little bit more abstract thinking. So you can draw something out. You could draw the sweets in the bag, or you could use a tens frame. Okay, got 3 sweets in the bag. I'm starting off with 3, and I add 2 more. So add 2 more. So we can add in 2 more sweets. How many have we got all together now? How many are in the bag? 3, 4, 5. There are 5 we can add on like that. Okay, so we're not going back, going 1, 2, 3, 4, 5. We've moved on from that now, and we're starting from the bigger number or the smaller number, depending on what order they're in, and we're counting on. Okay, if you need more practice where you are counting the more, then practice that. That's fine. Okay, build up your confidence, build up your fluency, and then move on to this. Okay, so the next thing, Fern has 11 fish. So we'll have Fern, and this is using something called the bar model, which I'm going to explain in a couple more sessions if you've not come across this before. So this is a really handy tool for working in a more pictorial and abstract way in maths. So Fern has 11 fish, so I'm going to draw a bar that represents 11. Okay, and she's got 11 fish. Now you can do this if you wanted to using a tens frame. You could make 2 tens frames. You could put 11 fish on there, 10 and 1 more, and then add on the next fish that she buys. That's fine. You can use counters. I'm just showing you some different ways of doing it. So Fern's got 11 fish. She buys 4 more. So 1, so 11, 12. Got 11, 12, 13, 14, 15. So each of these is worth 1. So we can write a number sentence, 11 at 4 is equal to 15. Okay. Another way of doing it you can use is a number line. So we could say, and number lines don't always have to start at 0. So James is 6 years old. How old will will he be in 4 years' time? We can start at 6 and we can count on 4 more. So start at 6, we can go jump 1, 2, 3, 4, start at 6, 7, 8, 9, 10. Okay. You might already have a number track you can use. You can use 100 square to practice counting on. There are lots of games that you can use for counting on. On the IC Maths website, which I've included a link to these games in the description section, there's a count on race, and that uses a dice, and that's practice on counting on 1 more, 2 more. But you can have a dice, or you can just have little cards if you only want to keep it to 1 and 2 at first. Put 1 on a card and 2 on a card, or get 1 and 2 out of a pack of cards, or the 1s and 2s. Take one out, and that's how many you need to count on. You can use number tracks, so get numbers on a track and place a car on there and count on to see how many. Roll the dice, count on that many, so start at the number and add on. You can draw number tracks outside, so using chalk, and you can start at a number, roll a dice and count on. Another way of doing this is hiding some counters. So here I've got 5 counters on a plate. Put them on a tray or anything, cover them up so we know there's 5, and I add 2 more counters. So I put that under the cover. How many counters have I got now altogether? Well, I know I started with 5, I added 2 more, so 5, add 6, 7, add 2 more, makes 7 altogether, and then we can check by counting them. Another little game to practice counting on. Now you can do this with bigger numbers if you like. With this, you can put some place value counters under here, some hundreds, tens and ones place value counters. Children work out what they've got under there now, then get some more place value counters, might be some ones or a 10 and some ones, put those in, or some tens, and see if they can count on from that. Another game, again, you can make the numbers bigger on here. You can start with bigger numbers. Throwing balls into pots, knocking skittles over or cans or something over, and adding them up together. So if you start with a number. So say if you got one into 8 and then you had to count on 3, 8, 9, 10, 11, or you might start with 6 and you have to count on 9 if you knock over the 9, or you throw your ball into the 9 counter cup as well. Okay, so lots of games there to practice counting on. The second thing that I said this session is about is the commutative property of addition. And all this simply means is that addition can be done in any order. So if we go back to our 7 and 2, okay, we had the number sentence 7 and 2. We started with 7 and we added 2, but we could easily start with 2 and add on 7, and it would be 9. So that's what we've been looking at and building up to, is that the addition can happen, the parts can be in any order. So if we've got 9 made up of 7 and 2, it doesn't matter what order we add those parts together, we will still get the total of 9. One thing that can happen here, what we've looked at in our last session, is that sometimes you can make a mistake, or children can make a mistake where they try and have the whole and add the part together to make the same number. That can't be switched around to make the same number. But the parts, if you move them around when you're simply adding, they will always make the same. So it doesn't matter what order you do them in. And that is the commutative property. And the reason that's good for addition is that it's easier and more efficient to start with a bigger number. Why is that? Why is it better to start with the bigger number? Well, what do you think? Have a think about that one. Okay, so I hope you've had a think about it. And the reason it's easier to start with a bigger number is because it is easier, it's more efficient, because you've already got that bigger number in your head. So here, if we've got 7 in our heads, or we've got 7 counters and we're only counting on 2 more. So 1 is quicker and it's less work for the brain, because the brain's having to do the work in there, so it's less work for the brain. And it also means there's less room for errors, because we're counting on less numbers, so we're less likely to make a mistake. So if you can, always start with the bigger number to count on, and that will really help you. Okay, you will find some activities in the description for today. Remember to share those with me. Remember to subscribe. Think of a brilliant, snappy slogan for me to use to get people to subscribe to the channel, and I will see you back for the next session, which will be Addition 4. Take care, bye.